Hi there. My name is Chris, and in this session, I will talk to you about the Open Container Initiative. You probably have used containers before. The question is, why are they so well known for being portable? Why are containers interoperable between different environments, different tools? And all of this boils down to this initiative, the OCI. So, what is the Open Container Initiative? Well, the OCI basically is a project from the Linux Foundation, and the main goal is to develop vendor neutral. This is very important. There is no dependency to a company or a set of tools. It's a vendor neutral and open set of standards to tell us about container formats and runtimes. So in practice, and in other words, what the initiative is telling us is an OCI compliant image can be built by any OCI compliant tool and also executed by any OCI compliant tool and distributed by any OCI compliant registry. So these are the three pillars of the initiative. We have images, runtimes, and distribution. So the main focus is really on core interoperability. It's a sort of closed ecosystem that lets any tool out there be able to understand what the container image should look like and how to distribute that container image and then how to execute it. So the typical flow could be something like you have a tool that is OCI compliant, and then you use it to build an OCI compliant image. You can distribute that image to an OCI compliant registry, and you can then pull images from that registry and run them with an OCI compliant runtime. So the whole initiative was founded more or less in 2015 by Docker and other container industry leaders. And the whole point is really to create these specifications, a baseline from where we can grow from to a point where there's a common baseline. And then we can start introducing and building on top of that. And for one example of this augmentation of the standards is that these days we actually refer to a container image as an OCI artifact because there are other types of OCI artifacts these days that we can also distribute through a registry. That is the power of the initiative. And that's why we want this set of open standards because it will allow different tools, Docker, Podman, Scopio, Auras, Rowcraft, to understand how to handle a container. For the remainder of this session, I will dive a bit deeper into the image specification because I feel like this is pretty much a common starting point for everybody. Where if you are trying to enter the world of containers, you would probably build your container image or you are going to create an instance of that container image, which is the container. So it's good to understand what is a container image, how is it structured. So what the OCI spec is telling us for images is that, hey, actually, if you take a step back, what an OCI image, what the container image is in very simple terms, a tarball of tarballs. Right? It's just a compressed file, and all of your contents that you are trying to pack inside the container image are structured by layers, as you probably already know. Those layers are also compressed inside this tarball. But additionally, on top of those layers, there's a set of metadata files. There's there are JSON files that will tell us whether what the layers are, right? Those are the manifests that will tell us, okay, I have this set of layers for this architecture of this image. There's also configuration files that will tell us other types of data about the image, like the entry points, the command, the labels, etc. And all of this all together creates this directory tree that we can see here in this slide that basically tells us how the image should be structured. And this is important because that's the starting point for runtime to be able to understand how to actually unpack that and run it as a container. What we are seeing is that first, using a common tool like Auras to interact with the registry and be able to list all the tags that I have in Docker Hub for the Python image. We can see that this is also possible to be done for another registry, the Amazon ECR. Again, because both registries are OCI compatible. Now, next, we are going to also use Docker, a different tool here, to pull an image and also run it. That also shows that because the tool, Docker, is OCI compliant, can speak with that registry and can run that container image. Now, one thing we can do is actually look at that image instead of being a sort of an abstract unit as an OCI archive. So we can copy it into our system as an archive. And if we look at that archive, it's actually what I was saying before, it's a tar. And I can look inside that tar and it will show me the structure we saw before. It's just an index file, an OCI layout file, and then a bunch of different blobs. And those are a bit cryptic to read, right? But the index.json file is our entry point. We will start there to let us know, and then it will let us know what is the manifest, what are the layers, etc. An OCI archive can actually have multiple images. So because for each architecture, you have a set of layers. So if I do the same command, but say that I want multiple architectures, you will see that now I have two images under the same archive, but still only one index.json file. So I can actually start there. It's just that I have many more blobs. And if you have more architectures, this list will grow. So the index.json, as the specification says, is your entry point. So let's actually extract this tar block into the system. Here we can use copy, just changing the format of the output, in this case OCI, or I could just basically use tar, the same job, doesn't matter. So here we have now this folder called Python, and if we look at the tree of it, it's going to give us, as expected, what we saw before and what we saw in the previous slide, that we have a set of blobs in the index.json file. Let's look at the index.json file. It will show us that we have a pointer to where to find manifests. That's what the index will tell. It's the other point, and it will tell, okay, for your OCI image, you'll have one or more manifests. And this will actually point us to an index. If you see the media type, it's not a manifest, it's an index, which in this particular case, because we have multiple architectures, is basically a manifest list. So let's go there. We enter and you will see, again, manifests. And now we actually have two items. It's an array of two different manifests. This is an index of what manifests the archive has. And we have two because we asked for a multi-arch, and this specific image has one set of blocks for AMD64 and another set of blocks for ARC64. That's how multi-arch is achieved. You are not going to have the same block in most cases for different architectures. So that means that if I choose to follow one specific manifest, which I did here for AMD64, you will get that manifest, which is specific for that architecture. And this manifest will tell you, now this is the actual manifest, it will tell you where to find the image configuration. Right? What are the layers that belong to this? Right? So again, we are going down the path, starting from the index all the way to the image configuration in these layers. So now we could look at the image configuration, following that digest, and it will give us something that might be actually familiar to you. You might have seen some of these fields before. And here we have the image config. We have a lot of config attributes, again, entry point, labels, and all that. And why is this familiar to you? Well, it is familiar because if you have ever executed the command docker inspect or scopio inspect or something similar, what it does is basically provide you a very similar output with those fields. Right? If I do docker inspect of the previous image that we are working with, we're going to scroll up and see all of the same config values that we just saw inside the OCI archive. Right? So that's basically the OCI image configuration according to the specification. Now, if we go back to the manifest, the other thing we can have a look at, as we saw before, is the set of layers. Okay. So now for this image, the AMD64 version of this Python image, we have 3 layers. Okay. And we can see the different sizes there. And we can see that they are basically tar files, tar and gzip files. So we can get again the digest because the name of the file, the name of the file will be the digest, luckily for us. And we are just going to look into one of those layers. We can see here that because it's a compressed file, we can just use tar again to see the contents. And as expected, that is a layer. That's the actual content of one of the layers that belongs to our container image. And this particular layer is basically, as you can see, as expected, file system or part of the file system of that container image. In this case, you can see that is installing our entry points that is payable. It has all the Python stuff that we expected from our image. So that's basically a layer, and we could put the same thing for all the other layers and also for the layers of the other architecture. So everything is well packed inside that OCI arc. And the final check there was just to say that you could also import this OCI image into something like the Docker daemon, because again, everything is OCI compliant. So that's the power of interoperability that these standards give us. Like it's vendor neutral. We could have done the same thing with any other tool that is OCI compliant. And the same thing would apply for runtimes and registries. If you want to know more about this, just go on and follow these links. We have a lot of information about containers in general in our own Ubuntu.com pages. You can also find the original sources for the OCI initiative under opencontainers.org or at GitHub, where they have all the different specifications and some tools as well. I'll see you the next time.